Hello, Bill Sell here with Innovator in the Room, a program with Desktop Engineering Magazine. We take a look at a number of different very innovative programs, products, opportunities out there for folks. And joining me today in studio, Steve Robbins, Executive Editor with Desktop Engineering, and Bruce Bradshaw with Object, your Director of Marketing. Thank you, and it's great to have both of you guys here. Steve, let's talk a little bit about 3D printing and the category and you know, who does this and what's this all about?
Sure. 3D printing is a very useful technique for building prototypes as well as building real pieces of equipment that you might be using in a number of applications. It has a great advantage for speed, and it has a great advantage for the ability to build things out of multiple materials, especially the reason that Bruce is here, because Objet has a lot more materials that they can supply for these than other 3D printing companies.
We had recently introduced some new materials, so we're at 107 different materials that can be offered, and again, a large portion of those are offered through our Connect technology. We have 17 base materials that's available in our Eden, and some of those material in our desktop line, but again, the Connect line is what brings you the 107 different materials that you can combine together.
Bruce, do you want to just touch on what digital materials are and how you do that?
It's actually taking two base materials. In this case, it's a what we refer to as Vero White. It's a rigid white plastic material. And what we refer to as Tango Black Plus, that's our rubber-like material, and combining those in a very precise way to get as many as 14 different mechanical properties in a single part. So it's taking two materials, giving you 14, printed all at the same time to print either separate prototypes that you wanted or to get different mechanical properties in your same part.
That's a very strong thing to be able to do. But there's another thing that Objet is doing recently, which is being able to build ABS plastics materials and combining two different kinds of ABS plastics into a unique material that has both strength and has thermal resistance.
Correct.
So it's used in a number of applications, and it's a new way of doing it. You haven't had this out very long, I think, for just since 2011.
Correct.
But it's being used in things all the way from the boardroom to in race cars that run around tracks.
Correct, and you know, it's used in a number of different ways. As you pointed out, it's actually taking our prototypes really to a whole new level. People are using them, although we don't bill it this way, people are using them as their finished products. It's also used a lot in the manufacturing process to make a jig or fixture in the manufacturing process. It's now tough enough and heat resistant enough to be on a manufacturing line, whereas before our other materials were really just for the prototyping world. These are actually being used in a much more different way.
Yes, you call it ABS-like plastic.
Correct.
But it's got the qualities of ABS plastic.
It does, exactly. And I had mentioned this in a previous show before. It's actually taking the best of both worlds from two different mechanical properties. So one of the challenges that happens in the prototyping world or in the materials world when you build or you produce something that's a tough material, the trade-off is it's typically not temperature resistant or high temperature resistant. On the flip side, if you make something that's high temperature resistant, it's typically very brittle. With our technology, because we can take the best characteristics of those two materials and combining them into one, with ABS-like, I get a high temperature material that's very, very tough. And that's an unusual material offered in the additive manufacturing space.
We're going to have a couple of examples coming up with that.
Yeah. We have our first interview, which we actually had done in Costa Mesa, while you guys are out at one of the industry events, and we were able to actually have Zehavit with Objet interview and talk with a number of the clients. The first one here is actually with Vista Technologies, Dan Mishek, and let's take a look.
Do you recall when was the first time you heard about Objet ABS-like material?
The first time I heard about it, it was probably rumors of 2009, 2010 of there's a really new material coming out that was really strong. So that's the first I heard about it.
Right, but the official announcement was April 2011, so probably last Rapid you heard about it.
Yes.
And I was really glad to see some of your applications that are using ABS-like so intensively. So maybe you can tell us a little bit of how the Objet ABS-like material is being used in your rapid prototyping cycle, especially that you have so many technologies on site. What makes it so special?
I don't know where to start. We have many applications that we have used for RGD 5160 ABS-like material. We have customers in the medical industry, we have consumers, we have electronical customers that are using this, and the biggest thing that we're seeing is that they're using it for more function, more diversity. One of the things that they're getting is they get the standard surface finish, the nice tolerance that comes with Objet technology.
Right.
So now they're gaining the functionality. So where they're excelling is a little better heat deflection, but where it competes with maybe FDM or SLS, where they're seeing great examples of functionality.
It's great to see what Dan's company, a service bureau, is able to do in a number of vertical sectors. And you know, this whole service bureau concept of being able to do some of this rapid prototyping really has become the next direction for many of the Objet customers.
Yeah, absolutely. There's a lot of service bureaus. Grow It is one of them. Dan, based in Minneapolis, Vista Tech, another one. So we do have a lot of installations of printers, but there are still a large amount of folks that actually go to service bureaus like those to get their parts. And again, the requests from end-use customers to people like Dan for the new material ABS-like is really been astronomical. Lots of people asking for it. And again, because its application use is so much broader than what they typically were getting from Objet materials.
It was interesting that Dan also brought up surfacing and that the parts look good. Is that just the ABS materials, or is it actually?
No, it's one of the neat things about our technology. It's because we're using inkjet technology. Really, the quality is the same from our $19,000, $20,000 desktop printer all the way up to the high-end Connex machine. It's the dot size and the layer thickness that gives you that resolution and smooth surfaces and accuracy for tolerances when you're trying to match two parts and things like that. So the technology is the same whether you're going from the entry level all the way up to the high end, and it's really the inkjet technology and how Objet's employed that allows us to get that quality across the product line.
Very interesting. If you're in the service bureau industry, you face a lot of challenges. You know, it's different customers need different things, and to be able to build parts that actually look like real-world parts is probably a very important part of what they're looking for when they're developing a business plan and looking to purchase some sort of printing.
Absolutely. You know, again, it's key for a service bureau. There's a number of characteristics. One is, again, for them, their product that they're going to give to the customer is the part, and the part should resemble as best that they can their end product. And that's really where Objet comes in, and that's really our hallmark, is whether you're going through a service bureau and getting a part through great organizations like Vista Tech and Grow It, or if you own the technology yourself, the real end game is to be able to resemble your end product in the prototyping stage better than any technology in the market.
Sure, you save a lot of time and money if you don't have to finish it.
Sure.
John Cross with Burton snowboards. It's not a heat issue and have that heat resistance there, but now it's actually become a cold issue. And will the product, the prototype, actually be able to withstand the very cold temperatures? Talk a little bit about what Burton's doing these days with the prototyping.
Sure. Burton's clearly known for snowboards, but Burton has a whole host of products that accompany those snowboards: bindings, goggles, backpacks that have zippers and things along those lines. So they're using the Connex technology in a number of different ways. They're using them to test the buckles on a snowboard, and they'll actually put a prototype on and head to the mountain. I've actually visited with John Cross and been there in the middle of the winter, and he'll pull out a new set of goggles and say, "What do you think of this, dude? Let's go to the mountain," and just like you would think, and throw them on. And they're actually out on the slopes testing these things in real-world conditions. And as you pointed out, it's not a heat problem; it's a cold problem. And in Vermont, in the middle of January and February, it's cold, and this stuff needs to hold up if they're really going to figure out, is this an end-use product for them in the prototyping stage.
Yeah, and plus they're building real parts because they're like buckles on the boots that they're actually testing.
Correct. Yeah, exactly.
Very
so
cool.
It's a neat facility. They definitely have a lot of different uses. And again, you think of Burton Snowboards as a snowboard company, but if you went to their website, you'd see all kinds of stuff. You can buy luggage from them. So the uses that they get and the application uses are really just a wide variety, and they're a great case study for the Connex technology.
Well, let's take a look at the clip with John right now.
Just curious to know what Burton do with this.
Okay, yeah, that's right. Last April was at the Rapid trade show, and that's when we first heard about the new materials, the ABS-like, the Vero Clear. You know, and that was a really exciting thing for us because up to that point, you know, we were using just Vero White and the digital material selection. Hearing about the new ABS and its toughness and thermal, you know, resistance was pretty cool. You know, lots of times I use my the printer for small component parts, maybe in a boot project, binding, buckle levers, just small parts that, you know, we wouldn't normally just start a laser sinter job for, and people may need these parts midweek instead of waiting for a weekend build.
Okay, so the ABS-like actually opened a whole new set of applications for you when it comes to toughness, I guess.
Yeah, you know, it basically made our Objet material more of a usable part. You know, we were able to like use the ABS-like material for, say, like boot lace guides in our speed zone system, like buckle levers that are going to be cycled.
Okay.
Yeah,
in a repeated manner, so
right.
And will not break.
Yeah.
So that's a major change, I guess. You feel the breakthrough here in terms of properties, don't you?
Oh, absolutely, yeah. No, it's great.
And breakthrough, it really is with what Objet's doing here. You have really gone way ahead of the competition, and if you're in this type of business where you need to do the prototyping in any kind of 3D printing, this really does seem to be the solution.
It's a rapidly, excuse the pun, adapted or adopted technology for us. There's lots of folks, whether or not they're looking at a desktop printer, they aspire to own the Conics technology because it really does allow them much more versatility, much greater flexibility when they're developing their products. And again, I've said this before, being able to resemble the end product in the prototype stage is key for them, and the versatility of the 107 materials allows them to do that.
You know, Bruce, it makes me think, you know, this program is called the Innovator in the Room, and you are obviously the innovator in the room. Okay. And the cool thing that's going on here is you're able to deal with the digital materials, and that's an innovation that you provided. But I know from talking to other places that have used your printers in different applications that they actually aren't just for printing prototypes. They actually allow engineers to become innovators. Mm-hmm. And often they don't know that until after they get their first printer. Mm-hmm. You've probably had some examples of that. Could you just discuss that?
Yeah, sure. There's lots of examples of it, and there's several that come to mind. One is Fishman guitars, and again, it's not it's our entry-level customer. They own a desktop, and they were sending out for prototypes, and they would use them to test their products in the development stage. But what they figured out once they actually got the printer in-house was they can actually put electronics in it, and they would go to their industry trade shows. They sell amplifiers and acoustics in the guitar industry, so they sell to Fender guitars and Gibson and those Yamaha and those guitars that we like. And they would go to their trade shows, and they would have an actual product that they would be able to show people on a trade show floor for a product that was going to be developed a year from now. And if they didn't actually get their FaceTime and were able to actually put that product in their customer's hand, they would lose a year of sales time if they didn't have these prototypes. So they started out saying, yeah, we're going to use it in an engineering phase, completely changed their business, and they actually use it now in the sales stage. So their sales team goes out with prototypes, working prototypes from our desktop machine, and actually helps them increase their business and sell more product.
That's like taking a year out of the cycle.
Exactly, yeah.
Amazing. And I know that we were talking to a bicycle manufacturer once who actually, the guys, unbeknownst to some of the management, were building parts and actually testing them on the track before they were being used.
Mike Ziegel and Guadalupe from Trek Bicycles are good friends of ours, and they actually, again, it's a very similar story where they were bringing prototypes in for one reason, and it expanded their entire prototyping world. They have CNC machines, and there was a backlog of like 2 weeks of getting CNC parts. And that's where most of the designers thought they would go to get their prototypes before they got the Conics machine. Now they go to Mike and Guadalupe, and they get their prototypes in 3 hours, 4 hours. And Trek's a very, very, very fun place. They encourage their employees to bring their bikes, and they encourage so they'll take a prototype, their designers and engineers, and strap them on their bicycle, and they actually have a track there, and they go out and put these things through the ringers. Yeah, exactly. So it's a fun story from a real world standpoint, and a prototyping standpoint all in the same thing. And they really put, when I say they put them through the ringers, they really do.
So are they using ABS plastics?
They do. They actually, they have a Connex machine. They use the ABS material. They develop helmets and handlebar grips and all kinds of fun things. And again, these guys ride bicycles a lot harder than I do. And with their course that they actually have there in Waterloo, Wisconsin is pretty amazing. And they really put it through the ringer. So it's
a place I'd like to visit
yeah,
sometime.
you should. You should.
Yeah.
It's a great place.
Yeah.
So looking ahead, what's the next step here? You're at 107 of these different properties right now, and anything left to discover?
Yeah, I mean, honestly, the possibilities are endless in terms of the materials. I mean, there's reality in what we can do in terms of material development, but the technology allows us to blend as many materials as we can. So, you know, the curve and the slope of where we're going with materials is very steep, and we're going to be bringing out more and more materials as they go. The neat thing about our technology is we don't leave the existing customers in the lurch. Our materials are typically backward compatible, so if you own a Connex today and we develop new materials tomorrow, you'll be able to use those materials in that machine when we come out with them. So we believe in the making sure that our customers are happy and that the investment that they've made in Objet is preserved.
Right. And the customer is actually able to replace the materials rather quickly. I mean,
correct.
It is
it's a very easy half-hour swap. It's not a vat of material or things along those lines. It's office friendly. They're not exposed to what's in a cartridge. They just swap them in and out. Depending on what material, they may have to bleed the lines because they don't want the material that's in the line to be in the next prototype. But it's a very simple process and easily interchanged.
Okay, well, for Desktop Engineering's Innovator in the Room series, this really has been a great example of some of the things that somebody could really come up with here.
Yes, very much so.
And 3D printing is just one of the many subjects. We're looking forward to a number of different programs.
Sure. The subjects that we deal with, you know, affect everybody that's an engineer. It's whether it's Bruce developing 3D printers, or it's an engineer working at Boeing, or some sort of medical device company. What we do is we are covering design software, simulation and analysis, the 3D printing and rapid technologies, and the tools behind those that enable the engineer to do them better, faster, quicker. It's all about optimization. It's about the fact that whether it's taking material off of a part to make that part less expensive and better to use, maybe in an automobile it saves some gas, or taking your time and doing things right so that when an engineer is working on something, they're not working for 3 months on a project that might take 2 weeks. It's all about saving time, money, and building better products. And building
really is the name of the game.
Better products is the key.
To find out more about things, Desktop Engineering at the website, desktop.
www.deskeng.com.
Desktop, yeah.
And Bruce's website for the 3D printers is?
www.objet.com.
Yep.
Very good. Well, thank you both for joining us today here, and thank you for taking part and joining us here at Desktop Engineering's Innovator in the Room.